In this unit, we're going to come back to introductory organic chemistry. When we looked before at compounds, what we saw was that we have this pool of substances that we can make in terms of compounds. And we talked about our ionic as being a small part, and we have simple binary molecular being a small part, and we have acids, which is even smaller. I gave you a list, and now we have the whole remainder of this that we're going to look at in this last unit. Okay, so this is going to be Introduction to Organic Chemistry. Chemistry that pertains to carbon is what we call organic. So anything that contains carbon is organic. So vitamins, oranges, spices, alcohol, Cheerios. All of those are carbon-based. Water is not organic. It doesn't contain carbon. Now, why is carbon such a big deal? Well, one, it is associated with living things. So all of these are things that are living. Alcohol is produced by things that are also living, corn and that sort of thing. But nonetheless, it's associated with living things. But chemically, it has a tetrahedral structure, which means it binds in 4 places. So a human being makes a decent model for a carbon because we can bind 1, 2, 3, 4 places. And what happens is these carbons can link together, right? Link, 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 and so forth. So we're going to form a link, form a link, form a link, and then we can bind in 1, 2, 3 more places, 1, 2 more places, 1, 2 more places, 1, 2, 3. And so a good way to show that, if we were in the classroom, we would all link together and hold hands, okay? But since we're not, I'm going to use pennies as my model. 1 carbon linked to a 2nd carbon, linked to a 3rd carbon, linked to a 4th, and so on and so forth. Remember that this is like holding hands, holding hands, holding hands, holding hands, but you still have 1, 2, 3 places to bind on the end. 1, 2 places to bind here. 1, 2 places to bind here. 2 places to bind here. 2 places to bind here, if I put another one, and 3 on the end. Okay, this is what we call a skeletal structure, where we're just looking at the way the individual carbons can rearrange. Now, the other thing about this is I can keep adding pennies to this or carbons to this, so it can link together like links on a chain, and that means it can kind of go on forever. The other thing that it has the ability to do is to form what we call isomers. And what that means is I can take this 1, 2, 3, 4, 5, 6 carbons in my continuous carbon chain, I can break a carbon off and I can put it somewhere else. That's called an isomer. I can take this one off, put it someplace else. Okay? I can put it here. And so you have to visualize, for example, 1, 2, 3, 4, 5, 6 in the longest continuous carbon chain. 1, 2, 3, 4, 5, 6 in the longest continuous carbon chain, that this is the same as this, not an isomer. But if I break off and I move this here, I have 1, 2, 3, 4, 5 in the longest continuous carbon chain, or 1, 2, 3, 4, 5 in the longest continuous carbon chain. And the one that's outside of the chain is the branch. Okay, these are called isomers, and when I break off a carbon and I move it somewhere else, I'm creating what is called a constitutional isomer. There are other types, but for this introduction, I'm going to stick with the easy one. Okay, so our demonstration would consist of getting pennies, and I would encourage you to pause and do this at home. Get yourself some pennies or something else that can emulate a carbon, so I'm going to grab a few more. Okay, so I'm just going to keep adding, and I'm going to keep adding, and I'm going to keep adding, okay? And what you want to do is you want to move these carbons around so that you get a new longest continuous carbon chain, okay? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. It's not always in a line like we're used to. So pause and practice that. Okay? Now, carbon is tetravalent, which again means it will bind in 4 places. Hydrogen will only bond in 1. So the very simplest kind of organic molecules I can make have carbon and hydrogen, and those are called hydrocarbons. CXHY. So I could have, say, 5 carbons. 1, 2, 3, 4, 5, and then I would have to put hydrogens on it. 3 here, 2, 2, 2, and 3. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So to make that hydrocarbon complete with 5 carbons, I would have to put 12 hydrogens on there. Okay? So practice this. If I only have 4 carbons, okay? If I only have 4, 1, 2, 3, 4. Okay, you can use your pennies if you want. 1, 2, 3, 4. How many hydrogens would I have to put on that? 3 on this one, 2 on this one, 2 on this one, 3 on that one. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. C4H10. Okay, so practice that first. Okay, on the next page. What we want to do is we have to look at these structures, and the simplest thing to do is to just put these carbons together in a skeletal structure, just like I did here. Okay? But instead of using pennies, I'm just going to write C. Okay? So my simplest thing is I'm going to have one of these. Okay? Carbon. And I know that carbon has to bind in 4 places. So I'm going to write an expanded structure. 1, 2, 3, 4, hydrogen, 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 hydrogen. Or I can collapse these hydrogens around that carbon in what we call a collapsed structure. Okay, so our formula is going to be CH4, and we name it according to the number of carbons. One carbon has the prefix meth, so we're going to call the name of this methane, and I'm going to come back to that in a minute. 2 carbons, going to link together like that. My expanded is that I have to put 1, 2, 3, 4, 5, 6. Okay, so I have CH3, CH3, and my formula means I'm going to tally everything, C2H6. Okay, I'm going to come back to the names in just a minute. Okay, my next one, I'm going to keep building. 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, 2, 3, 4, 5, 6, and you want to do this to 10 carbons and figure out how many hydrogens you need. Okay? Expanded. I'm going to draw my 3. 1, 2, 3, 1, 2, 1, 2, 3, and then I'm going to collapse these hydrogens around the carbons. CH3, CH2, CH3, and I'm going to tally everything. I'm going to put it over here, C3H8. Okay, so you finish the rest. In the next segment, I'll fill these in. This should remind you of when we did Lewis structures, and I said carbon is king, carbon is king, carbon is king, carbon is king. Remember? And I said we put these carbons together in the longest continuous carbon chain. And then you, quote-unquote, make carbon happy, and right now we can only make it happy with hydrogen. So you practice, you fill in the rest, and we'll begin segment 2 next.